To give you a little bit of background, TTL is a full service engineering firm specializing in civil and geotechnical engineering, environmental consulting, and construction materials testing. We serve the energy, construction, commercial, transportation, industrial, institutional, and municipal markets. And as I stated before, we're presenting today is Bo Cristwell. And Bo earned his bachelor's degree from the University of Wyoming in civil engineering. He has over 25 years of experience in construction engineering on various commercial, industrial, governmental agency construction projects. And many of those projects include reviewing field test data for compliance with the construction documents quality control program. He has served as lead special inspector on numerous projects, and he's managed teams of inspectors, and he schedules and coordinates inspections as required on project specifics for special inspections. Um, he is responsible for the reporting of inspections to the owners, designers, and of course, building officials. As I stated before, we do have time at the end for questions. Of course, if anything comes to you, feel free to unmute and ask. Bo doesn't mind. Um, you will be issued PDH certificates for attendance today, and those will probably be emailed out to all of the registrants next week. Um, and this presentation, the PowerPoint presentation, will be on the TTL USA website by tomorrow morning, and the video recording of this meeting will be available by request. So if you have anybody that's missing out or would like to see the video, that will be available as well. So without further ado, I give you all Bo Cristwell.
All right. Hi, guys. Thanks, Jennifer. This is Bo Cristwell. I work at TTL. And I like to kind of start out with our role in a lot of projects is we do environmental engineering. We also do geotechnical engineering, and we do construction material testing, and we do special inspections. So that's how we get involved in these projects. So I just wanted to kind of let you know that's what we do. And so again, common problems encountered in masonry construction. And here we go. Common problems encountered in masonry construction. Well, the common problems, there's a lot of problems, but some of the most common will start at the footing. It's always important to get the footing correct. And then I'm going to talk about some typical problems, and then I'm going to talk about some solutions to some common problems. And I'm going to put slides in here or photos to show these common problems. I don't have photos for all of it, but all the stuff I've experienced is in here, most of it. So here we go. So starting at the footing. Now, the footing is important. If the reinforcement is correct from the footing, it makes everybody's job easier. If it's not correct in the first course or two, you have to fight it all the way up. And if they get several courses from the footing up or from the top of slab up, and it's wrong, it's hard to drill an epoxy through a lot of courses of masonry. So it's always important to catch it, usually like the first course. If you miss it, it's tough. And if they lay up 8 courses, you can't even hardly see it. So, and the only way to repair it a lot of times is removing the wall. So if you catch it at the footing, it's the best. It'll make your life easy. Now this is a footing, of course, that supposed to have block laid on it, and they decided to pour concrete on here because, of course, this footing is, you couldn't lay block on this footing. So this is, so they decided, well, we'll just place concrete, then we'll pull the slab over. So they changed the design. So there are 2 contractors involved. Okay, there's a concrete contractor and there's a masonry contractor. And this does cause problems because these contractors work independently of each other. On a small job now, the concrete contractor will come in and do his work, and then the masonry contractor will show up to do his, and the concrete contractor will be gone. On a large, say, school or something that has many buildings, a lot of times, and it's nice that the concrete contractor's still on the job, And the masonry guy just shows up, and if he's missing doweling, the concrete contractor can come and do it, but that's not always the case. So the concrete contractor, he lays out the dowels and he lays out the vertical reinforcement for the masonry contractor without help or input from the masonry contractor usually. And, of course, then the masonry contractor comes back and he lays up several courses to the top of the slab, and the contractor comes back in and he pours the slab. It fills up those few courses above the footing. And when he does this, there's a lot of problems that get encountered. So problems that typically get encountered, I would say, is window openings. There's certain things that just aren't considered, like window openings. Okay, that might not be shown on a structural drawing, or when you're doing footings, you may not worry about where the windows are. So it's because you just don't think about it. Jambs, door jambs, you really don't care where those are either a lot of times. Control joints, they're usually shown in the structurals, but it's sometimes governed by architectural drawings. So control joints, they're typically missed, but they are shown in structurals. There'll be a formula, so many feet from the corner, or so much wall height, or it goes by a little formula. Beam pockets are tricky because when doing the footing, you don't think about the second story framing. Okay, you don't think about the roof framing. Well, beam pockets, for structural steel, they usually have 4 bars or 2 bars or 2 number 5s, and they may have stirrups, and they usually come out of the footing and go all the way up. So that's something that's very tough to catch, and you want to catch that during the footing placement. A change in wall height, that hardly ever gets caught. Lap splices out of the footing, and I'll show you some of those. Those can be difficult because the lap splice might look great, when you've got the footing there. Then you may put a few more blocks on there, or CMU, they'll pour the slab, and if they don't re-stick their steel, then their lap splice is too short. So these things are getting better, but they're still pretty common. Corners and intersections, of course, are always a problem. So concrete contractor has structural drawings and shop drawings, which may not show all locations for reinforcement. Structural drawings show typicals, which are applied throughout. Many times these typicals do not get applied during construction. Structural drawings typically do not show openings, control joints, etc. The concrete contractor also has shop drawings, which may show corners and intersections on the layout, but will not show openings and control joints. So a lot of these concrete guys, they may have a crew out there, and they may be doing the footing, and they're not really thinking about, wow, I need architectural drawings out here for this, because they just don't think about it. Well, architectural drawings show all your openings, shows your doors, shows your control joints. It may show the control joints in the slab. There's all kinds of things. The masonry contractor arrives on site and starts placing CMU. The masonry contractor will let you know very quickly it's not their job to drill and epoxy any missing dowels. And many times I've seen masonry workers lay block, either knowing or not knowing the doweling was wrong. And when notified that additional reinforcement is required, they've replied with it isn't really their job to place the reinforcement. Now they need to tell somebody else, and they'll just keep laying block. So there is a little bit of juggling going on right there. It usually will work out, but you have to stay on it as an inspector or to get overlooked. Because again, once they get up so high, you can't correct it hardly. It's hard because the wall's too high. And of course, by this time, the concrete contractor has left the site. So it always seems to be a conflict. Here's an example. There's a cut here. I think it's 4 on maybe 400, or can't quite tell. but I wanted to show you this for on 101. So here's a concrete wall. Here's the slab coming in, and here's some block wall. Now, what happened on this job is the contractor came in where he was going to pour his slab. Well, he went ahead and filled his block up and didn't really worry about it. And he left too short of a lap splice. And this is what you'll get. This was about 15 inches. And you can say, well, that's 16 inches right there. So, you know, that was like 14, 15 inches. Some were a little high, some were a little low. So the result of this being overlooked was you had to drill an epoxy, all the reinforcement, doweling. I also want y'all to pay attention to some of the scaffolding and these boards, some of the scaffolding boards, because I want to talk about scaffolding later. Here's another example. Again, there's a cut, I think 5 on SO2. I think it's 5. Yeah. And if you look at here, here's your footing. Okay, here's your center dowel coming up, you know, and that's the concrete contractor's job. Then the mason guy comes in and he just does this. Then the concrete guy comes back in and he does this. And you know, you just got a lot of trades back and forth. And so I want to show you this picture. So here's the footing. Here's the center of the footing kind of going through here. And then this is the doweling. Can y'all see that? How that dowel goes? So right here, you would basically, the dowel is all the way here. Sometimes it's off in the dirt. So you'd be laying your block out here on the dirt. This is a common problem. Happens quite a bit. Just want to show that to you guys. Again, reinforcing in corners and intersections. There's 1, 2, 3, 4 in this. There's 1, 2, 3 in this. This is common. This would be in the front of the typical sections. In structural drawings, in the typical sections, it might be in shop drawings too. It's hard to say. It'll be in a lot of different places, but it may not be on the actual plan view for the foundation. It usually isn't. Sometimes it is. I've seen structural drawings that it has had that, but not very often. And of course, you can see here our corners missing a few. This one they did pretty good. You see here, look at this spacing. They've just pretty much missed it all. Again, just common problems. You got to correct this. 1, 2, 3. So you should have had 3 in the corner. Again, should have had 1, 2, 3 in the corner. Then 1, 2, 3, 4 over here. And you see, since this wasn't caught right away, a lot of this will have to be tore down because you can't drill and epoxy this. It's hard to clean the holes out. You have to blow them and brush them and blow them and brush them 3 times. And then there's mortar droppings down in here. It's just very difficult if it gets away from you. Here's a step. I wanted to bring up this step. 8-inch step, 24 inches max. 8-inch step, again, if you're going to go more than 24 inches, you might have multiple steps. And the reason I put this in here, it's a concrete thing, but it's also a masonry thing. So here they were pouring this step, and I said, listen, you got to vibrate this. You got to consolidate it. So they said, okay. And then they started consolidating it, and they started saying, hey, it's blowing out. We're not going to consolidate it. So whatever. And then I go back, and this is what was actually out there. That's a 57. I don't know if y'all could see that. So that was a little more than a 24-inch step. So the problem with this really is, and we're going to talk about cleanouts later, but there's 8 courses. 1, 2, it goes up 8, right? And so from here down, you've got 1, 2, 3, 4, a rip, 5, 6, 7. You got 7 in a rip, so you almost have 8 courses there. So you'd have about 16 courses when they want to start pouring back here, and they'll just want to pour straight across this because they just for some reason want to ignore that. So that's something to keep an eye on. So when you're going stepping down and stepping up quite a bit, because some utilities can be very deep out there, so you just have to be careful. This again is a footing. Here's a pipe. You see this pipe? It's a utility, and there's some concrete. This doesn't step down and go under it or anything. They poured this. They wanted to pour it because they were going to lay the block straight across and straight across, and they probably would have pulled it off. And again, this is another thing. If you come out late, I had 7 courses. It used to be 7. 7.5 courses was a grout lift, and now or pour height, and then they changed it, so it's 8 courses now, so it's 5'4", which is 64 inches. But I was climbing across. There was a ladder across these 2 walls, and you can see it's already been sprayed. The wall's been sprayed with a water repellent, but I was pulling on this rebar to kind of cross over and go down the other side of the ladder, and I pulled this off. Well, this is what was sticking out of the wall. I thought this, well, it is the reinforcement. And when I looked at it, I was like, hey, your wall looks pretty good. I didn't see the whole thing, but looks like you've got it at the right spacing. And what happened was the wall was hollow and these were just stuck in there. So if you miss your inspections, you just don't know what you're going to get. The next thing I like to talk about is typical common problems. There's a lot of typical common problems, and probably one of the first ones you'll run into on a job is going to be the pour height, or the grout pour height or lift height. If it's a job that the wall tops out, 16 feet or something, they'll want to just try to pour the whole thing, and it runs into problems. But you can grout pour height and grout lift heights are addressed in the specifications for masonry structures, okay? TMS 60213, ACI 53013, and ASCE 613. I'll refer to this probably as just ACI 530 from here on out. Section 3.5C, Table 7, and 3.5D. So grout space requirements. So this is the cells. The cells in your is your grout space. And as these things are offset and they're built up and they have reinforcement in them and they have mortar protrusions into them, which by the way, shouldn't be more than a 1/2 inch to meet code, but it's very difficult to measure mortar protrusions and make them fix them. But if you had a 3x3 cell, which is pretty common, you could get that with fine grout and coarse grout. You could go up to 24 feet. Now you can't pour 24 feet at one time. Now, again, there's pour heights. That's a pour height. A grout lift can be 12'8". So if you did do the 24, you could only pour 12'8" at a time. You can't construct more than 24 feet though. So to pour a grout lift at 12'8", there's several conditions need to be met. The masonry is cured for 4 hours. The grout slump is maintained between 10 and 12 inches. And it's been a little while, but I'm thinking normally grouts 8 to 11 maybe. But so this needs to be 10 to 12. There are no intermediate bond beams within the grout pour. Now, if intermediate bond beams, this is right out of the code. If intermediate bond beams are present in the grout lift, limit the height of the grout lift to the bottom of the lowest bond beam. Now, I'm going to talk about cleanouts later, but this is where the code is a little, it doesn't make a lot of sense to me. And I've asked structural engineers and I've asked other inspectors, and it's always been a problem. It used to not be like that, but it is now. So if you went to the bottom of a bond beam and then you place 7 courses on top of that bond beam, all your mortar drippings would fall into that bond beam. And I just don't see how that could be good for your wall, because mortar may be 1800 PSI, and then it's drippings, it's not solid. So your lower course where your bond beam could have very, very weak mortar chips and things in with the grout. So I just don't, I think there's kind of an issue there. And grout pour heights over 5'4" require cleanouts, and I'm going to talk about cleanouts. Constructed wall height typically rates to grout pour height. I have included a slide which shows you low lift grouting right here. As you can see, no cleanouts are required. So he can go 5'4", he can go to there, and then he can lay block, and then he can pour 5'4", and then he can lay block, and he can do this. So he lays block to here, he lays block to here, and then he lays block to finish his wall off. Here is high lift grouting. Okay, so his pour height here, see, this is a 5'4" pour height, and it's a 5'4" lift. Here is a 12'8" pour with 2 5'4" lifts and a 2-foot lift. So cleanouts are required. So you can build the wall full height, and you must install the bar in solid, no splicing, in a solid bar. And so that bar, of course, is getting dropped in after. So that's why you don't want it tied. You want a solid bar. Also, I just will point out some things. If you do a wall this high, you've got to think about mechanical consolidation, and you have to vibrate that wall. So most vibrators don't have, I call it a stinger, I don't know the correct term, but where the probe comes out, they don't have one usually that is 12 foot long. I mean, normally they're short and they're battery operated. So that can be an issue. So even though you could pour this, you still need to vibrate it. And then now I think they've changed it where you can pour the whole thing and not do it in 5'4" sections. That was from a different standard, but I think it may be accepted now. This drawing is a little old. So cleanouts. So I mentioned cleanouts earlier. I had this slide in the beginning at first, and I moved it to the back some. So I want to make sure you guys understand what cleanouts are. So cleanouts are opening of a specific size and spacing for removal of debris from the bottom of the grout space. It's usually at the bottom course. And it's addressed in specifications for masonry structures, ACI 530, 3.2F, okay? So cleanouts are installed when grout pour heights exceed 5'4", which we said earlier. Cleanouts are installed in the areas to be grouted. Cleanouts in solid masonry are every 32 inches. So if it's not solid and it's just grouted where the reinforcement is, maybe the reinforcement's 48 inches on center. If that's the case, you'd have a cleanout everywhere there's a reinforcement bar at the bottom of the bottom course, in the bottom course of the grout space. Minimum cleanouts are roughly 3 inches by 3 inches. And I want to show you the importance of cleanouts, and I want to show you the importance of having too many courses without cleanouts. And I'm going to show you why it's important right here in these next few slides. Now, this is what I showed you earlier, the first picture. There was a footing here. Now, right here is solid, because that's where the slab's going to pour up to. So this guy said you need to have cleanouts in the bottom, right? In the bottom course. Well, he tried to get in the bottom course, and it was kind of solid, like over there. See that? Those are solid. So he went up and he said, these are empty. And I said, well, you got to take the face shells. I mean, you got to clean it out. They usually will take the face shell off. Now, if this was a clean out, it would be a square 3x3, or they'll punch a hole in it. And say this is going to get hat channel and gypsum board on it. Wouldn't be that big of a deal. They could put plywood over it, pour it, remove the plywood, and then put the gyp board over. But this is exposed, so they had to remove the face shells. And so when you remove the face, you can see this short bar coming out, where they had to actually drill and epoxy this bar in. But you can see the debris that's in here. These are mortar drippings. You see that right there? You see all that? That's why you have cleanouts when you get over too many courses, over 8 courses, because this is your bottom course, which is supposed to be maybe 2,000 or 3,000 PSI grout. And in reality, you have some 1,800 mortar if it was really good and not in droppings. But it's not like that. So you see, this is what's in your wall. So all this has got to be cleaned out, okay? That's what cleanouts are for. Now, a lot of times I've seen cleanouts put in and or not put in. I've had the contractor call an engineer or someone in charge and say, hey, can we just drill a hole in there? And when we drill a hole, we can see if, the grout's getting out, because it'll run out the hole we drill in the face. And so, and I've seen some of them get away with it. And the problem is, you can drill a hole in that right there, or in that, and grout will probably run out of it. But you just need to realize it's just not very good. You gotta be careful. Here's where they've missed some rebar in a wall. We had to go back, find where the reinforcement was missing. We had to revisit this area and come back. And so we located where the reinforcement needed to go. And so we had to clean this out so we could get in, drill down into the footing and replace. and put some reinforcement in this wall. This was a safe room, not a safe room, but it was a high security type room. Well, they didn't clean it out. And I said, nope. And they dropped it to right there. So, here, unreinforced at the bottom of your wall. And then it's not always that high. Here it was a little lower, but they just couldn't clean it out. Here it's a little higher. Speaking of cleanouts, I was on a project once. And so here you see this block. Now this foundation block, it's 8 by 8 by 16 nominal size. It's basically 7 and 5/8 by 15 and 5/8, and your mortar joint's 3/8. But this block is 4 inches by 8 inches by 16 nominal. And the thing about this block is, I like to say, so you have cleanouts, right? You can go every eight courses. Well, if you went more than like that block wall I showed you guys earlier, like this was, this was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 courses. And that was 13 courses. If you have something like this, okay, you normally can go 8 courses. Well, this is half the size of a normal block. So you could lay 16 courses of this block and meet code. So you just need to keep that in mind, why cleanouts are there. And if you've got more mortar joints, you have more mortar drippings and things you just need to remember. Next thing I like to talk about is bearing length, very common problem in lintels. Bearing length in lintels are shown on a lintel schedule, okay? And it's contained in the front of the structural drawings, typically in the front. And many times during periodic observations, bearing length of 8 inches will be found throughout most of the masonry. Smaller doors and windows, they have 8 inches bearing. Now, if the wall's getting up 8 to 10, opening maybe 8 to 10 feet maybe, then you have maybe a 16-inch bearing length. Now, storm shelter lintels can be very tricky because they have a lot of uplift. So they may have a 24-inch bearing length, but they'll have reinforcement along the 24 inches, which would be 3 cells. So here's a typical lintel you can see right here. Let's just look, for example, at 8 feet. If it's less than 4 foot, it's just 8 inches. Less than 8 feet, it's 2 block high, 2 CMU blocks with 2 number 5s in the bottom. It's basically 16 inches deep with 2 number 5s. If you look down here, it has an 8-inch bearing, okay? Those are typical. So when they do come up to 10 or they go to 12, you see how this changes at 12, you get a different bearing length. Well, they just miss that a lot. It's just a common problem. And storm shelter lintels are a little more complicated. You see right here, it says provide 24 inches of bearing on each end. And this, I couldn't fit all this on one slide. So it's 2 slides for the lintel of the bearing. So let's take a look at 8 foot 4 inches masonry, okay? So it's now 32 inches, where the other one was 16. This one's 32. So it's twice as deep. It's got A bars, 2 number 5. It's got 2 number 5 B bars. Doesn't have C bars. It's got 2 number 5 D bars, which is on the next page. But if you look down here, so there's the C's. It's like a hook, a tie. So, but down here you've got 2 number 5s. You got 2 number 5s. Even though this looks like a 16, it's actually 32 inches. So it's twice the depth, and it's got, 3 times the length on the bearing. And if you look here, D bars, these are D bars per cell. So you have quite a few D bars. You have 2 number 5s. And if you look at that, so you've got 2 number 5s here, 2 number 5s here, and 2 number 5s here. Now you also will look, you'll see there's some hooks in here. Extend the rebar 2 foot past the opening and provide hook. This hook comes, 2 number 5s is what we had at the top. So you got 2 number 5s and you've got 1, 2, 3 hooks. So you've got, they're matching D bars down here. So you got 1, 2, 3, And then up top, you got 1, 2. So you've got verticals in here too. That's 5. You got 5 number 5 bars. And this is going to lead me to the next thing I want to talk about, and that's congestion. You have to be very careful of congestion in reinforcement. For example, and I'll talk about that in just a second here, but I just wanted to finish this lentil schedule and tell you one more thing that's as a problem, and I see it all the time. So if they're pouring, let's say they're pouring this lift right here from here down, okay? And so what they'll do is they'll come through and they may stick their next piece of reinforcement in for the lap splice and so forth right here. Well, they'll still pour this solid. And so what will happen is they forget that there's actually hooks in there, because the standard procedure would be to just grout this solid from here down and then build the next section of wall. The problem with the storm shelter lintels is this section of wall ties in with this section. So they have to do their grout lift. They have to stay off the wall before they come up to the opening. So that's in storm shelters. That happens a lot. That's a big problem. Congestion of reinforcement, as I was just telling you, with the 2 upper bars and the lintels, and then 3 more hook bars, that's 5 number 5s. And then they each have verticals going through them, and that would make 6 number 5s. And so that doesn't leave you a lot of room for aggregate to get through, and much less a vibrator to consolidate the concrete. Corners can become very congested. Some of them may have, 2 number 5 bars running, and then some will put 2 corner bars in there. So that's 1, 2, 3, 4 number 5s. And if there's a vertical with a hook, 5 number 5s, and that can be an 8-inch wall, and that's almost impossible to get a vibrator through, and it doesn't get very much grout, and it doesn't meet the correct coverages for the code or anything like that. Hook bars into bond beams. Well, I just talked about that. So I want to show you a couple things here on bond beams located. That was congestion. I want to go on now to bond beams located in non-traditional locations. Walls that have double bond beams or triple bond beams, or maybe floor levels that has maybe a bond beam for the bar joist, and then maybe a bond beam above that to bolt angles to for slabs or things of that nature. Stairwells have metal stair pans. They get filled with concrete and they bolt inside these stairwells, and they have bond beams every so often. And if that's missed, there's nothing to bolt the stairwell to. And intermediate bond beams, those would be some maybe at 8 foot, say typically maybe on a wall, that a wall, and may have one in it 12, 8 foot or something that runs around the whole building. Easily to get those missed. Here's an example. Here's 4 on 4-2. This is a mezzanine. And you can see right here, the bar joist comes into this bond beam, which is a pretty strong bond beam, but it's 16 inches. And it's got an angle here where that bolts into it, and then the slab is poured on top. And this is really what happened when I went out there. None of the anchor bolts were in. They were missing, and you can't see them down here because I didn't go pull them out. It actually most all of this was missed, and there was an opening in here. We were called out to kind of check it out, and you could see there is some bearing plates, and so the joists are on the bearing plates, but the beam, the angle's being bolted into, the air here. This was supposed to be full according to the drawing, and it's not. So there, the bearing plate could be at the wrong elevation. This thing could maybe be built at the wrong height. It's hard to say. Anyway, here's a stairwell. Again, these brackets are going to hold up the stair pan. And this is another mezzanine, I think, at the top up here maybe. And they couldn't get their brackets in. So here they are trying to fill this. You can see it's not working too well. And then 1, 2, 3, here's where they've had to fill this bond beam in. They went back and punched holes in it. You can see right here, here's their stair pin. Embeds being misplaced. Quite a few embeds get misplaced. The beginning, I got a couple pictures I want to just show you. They can be at they can be at the wrong elevation. They can be horizontal and vertical. They can be wrong. All kinds of things. This was in the beginning slide. I didn't know if y'all noticed this, but this is some structural steel, and you can see it's been notched out. Not probably a great idea, but right here's the bearing plate, and right here on this bearing plate, this is an embed, and you see it should have probably been right here, but in the mason's calculations, he thought it goes up here. This is not an easy fix. This wall probably should have several vertical reinforcement, 2 to 4 probably. And then right here, you've got this plate, which has got shear studs or Nelson studs coming down, and all this is grouted. So a structural steel guy probably isn't prepared to work on all this. So he modified his work, and the mason probably has it in the wrong spot, but he's long gone. This I just put in. This is a homemade embed plate. It's kind of standard, but it's kind of got some bolts and extensions. I just threw it in there because you just never know what you're going to see. I don't know who invented this, but it's in there. Embeds, speaking of embeds, sometimes you have to drill and epoxy your reinforcement for your dowels. That being done, this was a tool a guy was using for drilling and epoxying, okay? He was, I think you have to blow it out like at 90 PSI, and then you have to brush it out. And I think what was going on in this case is he was actually using this. He was putting his lips here on the end, and he was just kind of blowing it out, and he called it good. Of course, and then I went through there and just pulled it all out. I mean, it wasn't working at all. So that's a special inspection too, by the way. Putting in embedments. This was supposed to be a Hilti type repair mortar. I mean, this was repair mortar, but epoxy, and on the job, it was actually mortar repair, maybe from Lowe's or something. I don't know. So you really have to check everything. Getting towards the end here, I like to talk about inspections. And I like to ask, say what's required for a masonry inspection, and then I like to talk about why it's not inspected. It's really pretty big deal. So you have a schedule of special inspections. Now that schedule is included in the plan assembly, and it can be included in the specifications. Some people may not want it in their plan assembly. They may want it in the specifications. It is in the construction documents. They're fine. And this is a pretty detailed one in the special inspection schedule. This is for a level B, and you can see like grout space. You have to periodically look at that. So you don't have to look at every piece of grout space, but you have to look at it, unless there would be cleanouts in there where you're supposed to look at it. All right, so 5.02, grade, type, and size of reinforcement. You would need to look at that. Placement of grout. You need to see in place, continuous. All right. Now you can also use the building code. The building code's probably going to refer you to ACI 530. It's going to be inclusive. And under typical inspections required by the building code, requirements for masonry structures, ACI 530. There's 3 levels. There's levels A, which is the easiest level. There's level B, and there's level C. Level C is the most stringent. Okay, so table 3.12 will list this, and I'm going to show you this table. Now, we'll get into this in a minute here. Let's see. So, for example, 3A, grout space. It's periodic observation. Grade, type, size of reinforcement, periodic. What that means is periodic. I mean, it doesn't mean you just kind of look at a little bit of it. It says you don't have to be out there the whole time they're working on it. You can go out and do an inspection, look at it all, and you can leave, or you can monitor the grout placement, which, as we've seen earlier in that particular example earlier, it was continuous, so you'd have to stay. 3C, placement of reinforcement, periodic. This is a continuation. It says continued. It's out of the code. Type, size, and location of anchors, including, other details of anchorage in masonry. This is what I want to talk about during inspections, is why it doesn't get inspected, okay? Masonry is typically, it's not a jurisdictional inspection. Masonry, what I mean by not a jurisdictional inspection, it's not what the building officials do, okay? So your building inspector is not looking at masonry. Now, he'll look at brick ties and things of that nature, but he doesn't look at the placement of the CMU. So if masonry, if empirically designed, it does not require special inspections unless it's in a category 4, a risk category 4. So, 4 is like hospital, fire stations, police stations. 1 is, dwelling with not many people. 2 is a category that has what's not in 1, 3, and 4, and 3 is a high occupancy area, but 4 is the one that you still have to do it if it's empirically designed, which just means it's kind of out of a code. Now, so what leads me to this next point is, if it's not jurisdictional and they're not looking at it, and it's not a special inspection and it's not getting looked at, well, guess what? Nobody's looking at that particular trade's work. So that trade, he's the guy that can do, doesn't get inspected like the electricians, doesn't get inspected like the plumbing, doesn't get inspected like the framing, doesn't get inspected like the concrete. Even though concrete can be a special inspection, a lot of times the jurisdictional building inspectors will come out and look at it. Gypsum board, the screw patterns. I mean, there's lots of in-wall inspections, lots of inspections on a building, but this masonry will slip through. So that's why it's important. If you're not getting special, if you should have special inspections, you probably need to get them, because the building official is not going to look at it. And you need to remember, somebody should look at it periodically, I would think. So that's the problem right there. There's other issues. The scaffolding can appear unsafe. The inspector may be afraid of heights. And I'll just show you a few things. This may appear unsafe, but this actually was safe. This passed an OSHA inspection. But just look at all this. I don't know. It's like the Incas built it. I don't want nothing to do with it, but it had to go up there. It was tricky. Here's another one. Again, very high. I took some of the other pictures out because they were too spooky. So, but if you're afraid of heights, or, it's not your cup of tea. So the last thing I want to wrap up with some solution to some common problems. Okay. Number 1, you could have a qualified inspector for special inspections. We do that work. And on the masonry, this is what we look at. We look at proportions of site prepared mortar. We look at construction of mortar joints. We look at element tolerances. For example, horizontal, vertical alignment. It's all in the code, it's spelled out. We look at the reinforcing steel, the type, the grade, the size, grade 60 probably. We'll look at that. So we'll look for those markings. The type, is it billet steel? Type S, if it's rail steel, it's not going to be, but you have to make sure. I found the wrong grade on several projects. Spacing and the required lap splice. Cleanliness of the reinforcement, acceptable location tolerances, and where it's located. Grout placement, grout space cleanliness, required coverages, and consolidation. That's what we look for in an inspection. Excuse me. You could also, possible solution would be to require a representative from the masonry contractors company to be present during the layout of the doweling during the footing placement. That would be a lot of help. That would save a lot of problems, because this is what happens usually. They will drill and epoxy additional reinforcement during the masonry layout, and there'll have to be some dealings to get this done. Shop drawings and structural drawings could be improved. I don't know if it would help that much because you have architectural drawings that can be used along with these two. Some, like I said, I've seen some structural drawings that show it all, but we still had issues. So no, masonry contractors typically work with electrical, plumbing, mechanical contractors for setting electrical boxes, plumbing openings, and duct openings. So they do work together. It's not, I want to make sure y'all don't think the concrete guy, contractor, and the electrical contractor can't get along. That's not the case. They're just not on the job at the same time. And there's the bonus picture. I don't know if anybody knows what's going on here. It doesn't look like anything's wrong, except this is the mixed water for the mortar. And that about wraps it up. We got about 10 minutes left for questions.
Yes, let's open up the floor. Does anybody have any questions that they may have for Bo?
I put him to sleep.
Hey, I've got a question. I'm going to try to field it from memory because it came up really early.
Okay.
Yeah.
So you were talking about, it looked like you didn't agree with the grout lift to the bottom of the bond beam. And I've always kind of wondered what's best practice here. What do you recommend as far as setting up your design to work with what is a good process for placing those lifts relative to the bond beam elevation?
Right. So, a lot of times, so by code, it's 5 foot 4 inches. It used to be 60 inches, which was between 7 and 8 courses, and they would pour to the middle. And then what happened is after that, they would forget they were supposed to pour to the middle and pour to the 8th course. So finally it got changed to 5 foot 4 inches. Now I'll see a lot of things in the plans. A lot of people will not worry about the code. They'll say, I've seen 4 foot lifts. They'll say, I'm going to do 4 foot lifts, or I'm going to do 5 foot lifts. But now when I see an intermediate bond beam, what we've always done, so if there's one at 8 foot, or they'll try, it says 8 foot minimum, and maybe you can bump it up some. So what they try to do a lot of times is put it even with the header at the top of the windows for the intermediate, and then pour to the top of it. And you're not building on top of it. But if there is an intermediate, I wouldn't build beyond the top of the bond beam. If that happens in the past, I've seen them build 2-story building, and where the bond beam is in the middle of the building, you had to go in there, and I suggested we put cleanouts in there as often as we needed to clean the bond beam out, get all the mortar drippings out. But then again, you've got to vibrate the thing too, so you don't want to get too tall. I'm not sure, was this Adam?
It was, yeah.
So I don't know if I answered you 100% on that. I'm trying to turn my speaker.
Well, honestly, I think you did. And what's interesting is this is a presentation for you guys in Tennessee, and on the West Coast with the seismic detailing, we have bond beams of 4 feet all the time. That's really common.
Yeah.
And I run into that question as to where should we place it, at the top of the bond beam or the bottom of the bond beam?
It makes no sense to place it to the bottom, to me. I don't understand at all. Why would you want to put grout to the bottom? Why would you want to pour through your bond beam? Why would you want to pour through it, coat the rebar with, some grout, and then build courses of block on top of it? It just seems like you would just make the bond beam polluted, if that makes sense.
Yeah, that's masonry too. Sometimes there's no real good answer.
That's right. That's right. But I think it's a mistake. I mean, I really kind of would like to contact them, because I just think it's a mistake. I mean, it makes no sense.
Yeah. Well, thank you.
You bet. You bet, Adam. Thanks. Anybody else?
Any other questions? Yeah. All right. Well, hey, I'll take this time here to remind everybody that you will receive PDH certificates to the email you registered with. If you have anyone in your office that watched with you, but maybe not registered, but would need a certificate, you can reply to that email and let us know. the presentation will be on the TTLusa.com website by tomorrow morning. And of course, if you need the video, when you register, you probably saw an email that said bcleveland@ttlusa.com. You can let Barry know at that email address that you'd like a copy of the video, and we can make that available to you. One more time, any other questions before we call it a day? All right. Thanks everyone for participating, and everybody have a great day.
Thanks, guys.
Thank you.
You bet.
Thank you.